Okay, welcome back. I'm now answering again a question from the P1 IAL Pure Maths 1 book, textbook. It's from chapter 8 on differentiation, and it's actually the very last question in the final chapter review, question 18. I've had a request from one of the students to answer this question, so I will go ahead and do so. Okay, so this question is asking us, or telling us, we'll just deal with part A first on its own. Okay, so the question is basically showing us a diagram of a quadratic curve, y equals 5 minus half x squared. Okay, and it's got it for where y is above 0, so it's like above the x-axis. And they told us that there's a point P which lies on the line, or on the curve, and O is the origin. Show that OP squared equals a quarter x to the power 4 minus 4x squared plus 25. So basically OP squared is the square of the distance between O and P. Now, P is a point which can vary. Okay, it can be any point on the curve. Alright? So where it is depends on its x and y value. It can be anywhere on the curve. Okay? Those are all the possible points where P can be. So we want to find an expression for the square of the distance between O and P, which is basically using Pythagoras. Okay, it's like using the distance formula for the point P to the point O. So it's like you have here that distance and that distance. Okay, if I find this distance here, which is the change in y, and here the change in x between O and P, then I can find OP squared. OP squared equals this side squared plus that side squared from Pythagoras' theorem. Okay, so what I've got to do is I've got to express the point P in terms of x. So the x coordinate is x, and the y coordinate will be 5 minus a half x squared. 5 minus a half x squared. That will be the y coordinate of P. Okay, that's the y coordinate of P. So when x is 3, for example, the y coordinate of P will be 5 minus a half 3 squared. Okay? So we can use the fact that the change in y is the y coordinate of P minus 0, which is the y coordinate of O. So it's 5 minus a half x squared. And the change in x is basically x minus 0. Okay, so by Pythagoras I can say OP squared is equal to x squared, okay, which is this, okay, plus 5 minus a half x squared squared. Okay, the square of the hypotenuse is equal to the sum of the squares of the two shorter sides, so x squared plus 5 minus a half x all squared. So I can say OP squared is x squared plus, now that's going to give me 25 minus, you're going to have 2 times 5 times a half, which is minus 5x squared. And you're going to have the square of minus a half x squared, which is plus a quarter x to the power of 4. So OP squared will be x squared. Well, let's put it in order, starting with the one with the highest power, as I have. You'll have a quarter x to the power 4. Okay, then you have the x squared terms. X squared minus 5x squared is minus 4x squared. And the constant term plus 25. And there we have it, as required. We have exactly what they want. Okay? So it's just a case of expressing the y coordinate in terms of the equation in terms of x, and then using the distance formula basically. This is the distance formula, but they want it as OP squared. So you don't put the square root sign. Okay, so that's the first part of the question. Then we have the second part of the question, which is over here. Let's just move this stuff up. Okay, we have our graph there. We have our question there. Okay, so part B says, taking f of x as what we found, find the values of x for which f dash of x equals 0. Okay, so f dash of x equals 0 is we have to basically differentiate this. So when we differentiate, so we have fx is a quarter x to the power 4 minus 4x squared plus 25. F dash of x, which is the differential of that, is 4 times a quarter, which is 1, times x to the power 3, and 2 times minus 4 is minus 8, x to the power 1, and the constant term disappears. And it says find the values of x for which f dash of x equals 0. So when f dash of x equals 0, we have x cubed minus 8x equals 0, in which case we can say x times x squared minus 8 equals 0. So x equals 0 and x squared equals 8. So x is equal to plus or minus 2 times root 2. 2 times 4 is 8. Okay, so 4 times 2 is 8. Sorry, 4 times 2 is 8. So you take the 4 out of there. So x equals plus or minus root 2. Okay, so those are the values of x for which f dash of x equals 0. Okay, that's for the distance between O and P squared. Okay, so hence or otherwise find the minimum distance from O to the curve. Now what we found in this expression here, is an expression that tells us the square of the distance between O and P. This expression is an expression for the square of the distance between O and P. Okay, so when we found in part B the differential of this, okay, and we equated it to 0, we're finding basically the minimum, okay, because this is like a quartic curve. It's going to look similar to a quadratic. It's going to go down and up like that. Have some sort of, it will kind of go like this 3 times, but anyway, could do that, but it's that same type of quadratic thing. It comes down and goes up again, okay, like a smiley face. So it's going to have a point where it's the closest distance, okay, to 0. So basically it's going to be, there's going to be a point, okay, this will give us a value when we differentiate it, okay, and we equate it to 0, it will give us a minimum value for this. So that's the minimum value of the distance between O and P squared. The minimum square of the distance between O and P. That's what we got when we differentiated and make it equal to 0. Okay, so now it says, hence or otherwise, find the minimum distance from O to the curve, showing that your answer is a minimum. Okay, so what we got to do is, okay, we know that the values are x equals 0 and x equals 2 root 2 and x equals minus 2 root 2. Right, those are the values of x, okay, for which the gradient is equal to 0, okay, of the square of the distance. So basically what we got to do is we got to decide which one of these is a minimum. Okay, so we're going to take the second differential of this. Okay, so we're going to have to find f double dash x, which gives us 3x squared minus 8. Okay, so if I put 2 root 2 in here, I'm going to get 3 times 4 times 2, okay, minus 8, which is going to give me something that's positive. And I'll get the same value for x equals minus 2 root 2 in there. I'll still get a positive value. Okay, so both of these will give me minimums, okay, but this will give me a maximum. Okay, because when I put 0 in there, f double dash of 0 is going to give me something which is negative. It's less than 0. Therefore, this is a maximum. But these two values will both give me minimums. Okay, so I know when x equals 2 root 2 or x equals minus 2 root 2, I'm going to get a minimum value. Okay, so now what I'm going to do is I'm going to substitute these x values into our equation for the distance, which is this. Okay, so it doesn't matter which one I put in there, because they're both going to give me the same value, because this is to the power of 4, this is the power of 2, they're going to be squared. The minus sign is going to be squared. So we can say that taking any one of them, let's just take the positive one. So OP squared is equal to Remember, it was a quarter x to the power 4. And what was the other thing? A quarter x to the power 4 minus 4x squared. Minus 4x squared, and I think it was plus 25. Yes, plus 25. That is an expression for the square of the distance between the point O and the point P. So we know that when x is equal to 2 root 2, or plus or minus 2 root 2, you're going to get the minimum distance between O and P. So let's find out what OP squared is going to give us here. It's going to give us a quarter times 2 root 2 to the power of 4 minus 4 times 2 root 2 squared plus 25. So you get OP squared. Okay, so that's a quarter. Now 2 to the power 4 is 16. Okay, and root 2 to the power 4, well, that's like 2 to the power of a half raised to the power of 4, so it's 2 squared, which is 4. Okay, minus 4, 2 squared is 4, times root 2 squared is 2, plus 25. So you got OP squared, OP squared, looks like an 8 now. Let me just sort that out. OP squared is equal to, that's 16, minus 4 times 8, which is 32, plus 25. So OP squared is equal to minus 16 plus 25. So OP squared is equal to 9. 25 minus 16 is 9. So OP is therefore equal to 3. So the minimum distance between O and P is 3 units. Okay, and we justified it's a minimum because we know that when we put root 2 root 2 or minus 2 root 2 into the double differential, we end up with something which is going to be greater than 0. This is going to be positive. This is 3 times 8, 24 minus 8 is greater than 0. So therefore it's going to be a minimum. Okay, as when f double dash x is greater than 0, then the point that you put in there would be a minimum. Okay, if it's a turning point. And there we have the answer to this question. Okay, thank you for listening.